Today we are going to discuss a very important topic of 12th physics, that is capacitor. So what is capacitor? Basically the capacitor is a device, capacitor is a device that stores the electrostatic energy between the two conducting boundaries in the form of electric field. So the capacitor is a device that stores the electrostatic energy between the two conducting boundaries in the form of electric field. The ability of a capacitor to store the energy is known as capacitance. So capacitance क्या होता है? Capacitance is basically the ability that it can store the electrostatic energy. The ability of capacitor to store the energy is known as capacitance. There are lot of type of capacitors are available in the market. On the basis of that, what you have used. So the simplest form of the capacitor we will use it, and the very important for our JEE upcoming exam purpose is parallel plate capacitor. The fundamental principle, before moving to parallel plate capacitor, we will find out what is the fundamental principle of this capacitor. So whenever we provide a charge to a conductor, like this is a conductor here, the area of it is A, we are providing a charge to it. Whenever we are providing a charge to this conductor, then its potential increases. It means the charge provided to a capacitor, to a conductor, is directly proportional to its potential. If we are increasing the value of the charge, the value of its potential will be increased. And Q equal to C into V. C is what? Capacitance. Each and every capacitor have certain limits up to how much value, up to how much it can store the charge. So V equal to Q upon C. So whenever we have to find out the value of capacitance in any of the question, we have to find out just the potential difference, and after that we can easily calculate the value of the capacitance. Let us discuss the parallel plate capacitor. So this is a simplest parallel plate capacitor. These are the two parallel plates kept at a distance d from each other. This is your plate A, this is your plate B. The area of both of these plates is same, like the cross-sectional area of it is A, and it have also the cross-sectional area A. The plate B is grounded. Why we are going to be grounded? That we will discuss later. As we know that whenever we are going to provide the charge to it, then due to the induction, a charge, opposite charge minus Q will be appear to the plate B. The magnitude of this negative charge will be equal to the magnitude of this positive charge, but nature will be different. Now, what will be the value of electric field at a point P between these plates? At any of the point P, what will be the value of the electric field? As we know that the electric field at point P, due to that, the electric field lines due to that is outward. So E equal to sigma upon 2 epsilon naught. The electric field lines due to this negative charge will be inward, and due to that this will be also sigma upon 2 epsilon naught in this direction. Hence, the net electric field at point P is sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught equal to sigma upon epsilon. As we know that sigma is nothing but surface charge density. Sigma is q upon a, that is q upon a epsilon. Epsilon naught is what? Free space permittivity. In the chapter of electrostatics, we have studied the value of this free space permittivity is 8.85 into 10 to the power minus 12 Newton meter square plus minus 2. Now, the potential difference, if we want to be calculated, then as we know that V equal to E into E. So V equal to Q upon A epsilon naught into T. Okay. Now, V equal to Q upon epsilon naught A upon B. And Q upon V equal to Q upon V equal to epsilon naught A upon B. Very simple. And in our previous topic, we know that V equal to Q upon C or C equal to Q upon V. So C equal to epsilon naught A upon B. This is the capacitance of a parallel plate capacitor. Very simple. See, the capacitance of a parallel plate capacitor is directly proportional to the cross-sectional area and inversely proportional to the distance between them, between both of the plates. Now, we are going to be discussing more about this. Like, we are interested to find out the capacitance of a spherical plate capacitor. So this is a spherical plate capacitor. Okay. So this is a sphere A having radius R. This is a sphere B, outer sphere having the radius R2. These are basically concentric spherical shells. If we are providing a charge, this Q, then due to the induction, a negative charge will appear here. Let's suppose the radius of this is R2. We are interested to find out the capacitance of this mechanism, of this system. Hence, the outer surface of this sphere we are going to be grounded. If we are going to be grounded, we know that the potential of it becomes 0. Now, by the definition of capacitance, if we want to be find out the capacitance, we have to find out the potential difference between them. Hence, at a point A, if I want to be find out the potential at point A will be due to this sphere, that will be kq by r1, and due to this sphere